Welcome to LupoScan Tutorial 1. In this tutorial, you will learn some of the basic functions of LupoScan. First, download the data for this tutorial from the link provided in the description of this video. Then, import the data into LupoScan by dragging and dropping the folder containing it into the left section of the screen. Open the Scan tool. Since the scan contains color and RGB button is already active, the scan opens in color view mode. Each scan can be displayed in different view modes. You can switch between them by right-clicking on the scan and selecting the option from the context menu. Switch to Intensities view. There's a double slider below the scan that allows you to adjust the brightness of the scan by moving it to the left or right. Take a look at other view modes as well. LupoScan allows you to measure distances in the scans. To do this, activate the Measure Distance button. That opens the Measurements tab, where the results will be displayed. Let's measure the width and the height of the door in the central part of the scan. Zoom in on the door using the mouse wheel and measure it by clicking 2 points on the door for width and height, respectively. The result is also displayed in the left section of the screen, along with the coordinates of the start and end points that also can be saved as a separate text file. Press Escape to exit the command and change the view modes to color. Each scan in LupoScan can be visually represented in 3 dimensions as a point cloud. In the Point Cloud dialog, you can set the color of the point cloud. Increment controls the density of the point cloud. Set the increment to 2 using the mouse wheel. This means that every second row and column of the scan will be used to calculate the point cloud. You can choose to display the entire scan, a specific section, or multiple scans at the same time. If the scan contains color, the points in the point cloud will be displayed in their corresponding colors, just like in this example. Close the 3D window and the Point Cloud dialog. Another way to visually represent laser scans in 3 dimensions is by creating a mesh. Just like in the Point Cloud dialog, you can specify its color, increment, and whether the entire scan or just a selected section should be visualized. In the Edges field, you can choose between a triangular mesh if the value is 3 or a quadrilateral mesh if the value is 4. The maximum side length defines the maximum length of an edge in the specified triangle or quadrilateral within the mesh. The maximum side relation determines the allowable ratio between the edges' lengths in the mesh. A value of 1 means that only meshes with 3 or 4 identical edge lengths are allowed. On the other hand, a larger value, such as 10 or 20, allows very narrow, elongated meshes. Set the parameters in the Mesh dialog as shown in the video, and select the section of the wall you want to visualize as a mesh. Enhance the details in the mesh by switching lighting on and off. Close the 3D window and the Mesh dialog. Switch back to the Files tab. In LupoScan, you can extract sections from laser scans. The simplest way to do this is by using the Quick Sections function. Similar to the previous dialogs in this tutorial, you can specify the color of the section, the increment, and whether the entire scan or just a selected area of the scan should be used for the calculation of the section. A section plane can be parallel to the XY, XZ, or YZ plane of the current coordinate system. Additionally, it is possible to use any arbitrary plane created in the 3D view. In the field distance, we define the distance between the section plane and the section to be created. If the drag to value box is checked, points can be projected onto the section plane. Tolerance is the distance between the section plane and the points above and below it, or left and right, depending on the plane. Only points within this distance are used for calculation of the section. Number and interval specify how many sections will be created and the distance between them. If the change color checkbox is active, each section will be displayed in a different color. If you check lines, points will be connected by lines. However, this can result in a large number of them. The reduce function decreases the number of lines by averaging and joining them into longer ones. Maximum gap specifies the maximum distance at which points should still be connected by lines. In this tutorial, we will create 3 horizontal sections, each 50 cm apart, starting at a height of 2.5 meters. The sections will be displayed in different colors. Start button will begin the calculation. The sections will appear in the 3D window. View the results from different perspectives. Also, you can always change to the orthogonal view by clicking the Switch Perspective button. To better understand the results in the 3D window, you can project the sections onto the laser scan using 3D to 2D function in the Extra menu. Keep the default parameters, press Start, and observe the results in the scan. Hover the cursor over the lowest section to see the Z value of 2.5 meters at the bottom of the screen. The section above will be 50 centimeters higher. Close the dialogues and 3D window. Press Escape to clear the scan. One of the key functions in LupoScan is the orthophoto. The simplest way to create an orthophoto from a single scan is through the Quick-Orthophoto function. Open the Quick-Orthophoto dialog and activate Measure Single Point button if it's not already active. In this tutorial, we will create an orthophoto of a wall section. To do this, we first need to define a projection plane. Measure a couple of points on the wall. Their count will be registered at the bottom of the dialog. In this case, we don't need the projection plane to be perfectly vertical, so under Orientation, we'll keep the option Any active. The size of the projection plane is determined by the measured points. In the Extend field, you can expand it uniformly in all directions by a specified distance. Extend the projection plane by 1 meter. In the Tolerance field, we specify the distance in front of and behind the projection plane. All points within this range are used to calculate the orthophoto. If the resolution is set too high, some pixels in the orthophoto may remain unoccupied. Activating the Fill checkbox ensures these pixels are automatically filled through the interpolation. Set the resolution to 5 mm. In the first step of this tutorial, we saw that every scan can be displayed in different view modes. The same applies to orthophotos, but with an additional view mode called Edge View, which enhances the edges. We will keep this checkbox active. Clicking the Start button begins the calculation. Click OK to confirm the given resolution. Once the calculation is complete, view the orthophoto in different view modes. Pay attention to the clearly visible edges in Edge View. You can also check the distance between the projection plane and each pixel of the orthophoto. For example, switch to the Distance RGB view. Right-click on the orthophoto, select Cursor Info from the Context menu, and then select D. Afterwards, switch back to the color view. Similar to scans, orthophotos can also be visualized in the 3D window as a point cloud or mesh. Additionally, you can send both the projection plane and the orthophoto itself to the 3D window for further analysis. To do this, right-click on the orthophoto and select Plane to 3D and Orthophoto to 3D respectively. Close the 3D view and orthophoto. Right-click on the scan and select Clear to disable cursor info and delete the previously measured points on the wall. You can also add geometric elements to the scans in LupoScan. Open the interactive dialog and ensure the Measure Single Point button is active. In this example, we will vectorize the ceiling and corners of the room shown in Scan 2. In the interactive dialog, select Polyline. The corners are even more visible in the normal or spotlight view. Switch to one of these views and draw the polyline. Enable the Close checkbox and click Insert. A closed polyline will appear in the 3D view. Select Line in the interactive dialog and change the color to green. Right-click on the scan and choose Object Catch from the Context menu, or press the F3 key on your keyboard. Next, draw lines along the corners of the room, starting from the already digitized points on the ceiling. The Object Catch cursor will help you click precisely on these existing points. The lines will be automatically inserted into the 3D view. Return to the interactive dialog and select Height. Set the parameters as shown in the video, then switch back to the scan and measure the floor heights. The results will be automatically added to the 3D view. Save the 3D view but leave it open. Right-click on the scan and choose PanoView from the Context menu. The scan will now appear in the 3D view. Use the mouse wheel to zoom in or out and look around the room. You can also rotate by activating Rotation button and holding the left mouse button. You can also measure distances directly in the 3D view with the results displayed in the Measurements tab. Additionally, you can add elements from the interactive menu while in PanoView. Add a line and use the Object Catch cursor as in the previous step.